So you've decided to do DevSecOps against all best advice. No, seriously, DevSecOps is a good idea. But what does it really mean? Like, what are you doing? Is it worth doing? What's going to change from what you were doing yesterday? Let's take a look at that. So, DevSecOps is the latest buzzword. Lots of people are excited about it. It's supposed to be the panacea. It's going to cure all of our application security problems. It's going to make DevOps move really fast. It's going to make development go fast and have security not slow you down. So I wanted to talk about that for a second because a lot of people seem to think that DevSecOps' purpose is to simply do security testing earlier. Now, there's an old adage, and you've heard it from me before, and you'll hear it again, which is you can't test security into software. We know that you can't test quality into products. That's been well known since the 50s, the 1950s, and maybe even earlier. But the same is exactly true of security. Simply testing doesn't secure your software, it merely exposes the problems in your software. So it's very important to make sure that you're doing the right thing, not just testing the right thing. Okay, where was I? Train came and I got all distracted. I like watching the train, even if it's just a little commuter train just coming in for a stop. I still like it. So, testing security into your application can't be done. Don't do it. Don't try it. It's not a thing. By the way, it's pretty much what people think they're doing when they hear DevSecOps. So here's the point. When we do testing, say we've built our whole application or doing penetration testing to see if we can get in. This isn't to make the application better. It's to see if it's broken. The perfect goal of testing, whether it's security or quality or safety, software or hardware, is to validate that the thing that we're poking at does indeed do what we want and not other things. So from a security perspective, from AppSec, cybersecurity, software security, what we're interested in is an application that doesn't let us penetrate it. So penetration testing is interesting in the sense that it tells us if we did a good job. But if penetration testing succeeds, it means we didn't do a good job. So we can go plug those individual holes, but the application is still not well constructed. And that can really be a problem for us. We have to ask ourselves, why is it that I can get into this application? If I keep finding ways to perform SQL injection, cross-site scripting, and other attacks, I have to ask myself, why haven't I improved my application to the point that these things don't happen anymore? And really, when different things are happening, again, in the hardware world, we start to fix those things. And then we put in place mechanisms to catch them earlier, like DevSecOps, right? Run the pen test earlier before we deploy. And then we put in place things that would prevent them from happening in the first place. So really what we need is pen test runs early. It runs as soon as you can, relying on things like service virtualization and tests like Selenium and others that can execute essentially secure web application unit tests, which is kind of cool. And then you say, well, what if the whole application isn't there or not enough of it for me to even use service virtualization to get my way around the rest of it? What if I only have just some small components? That's where SAST comes in, right? The static analysis, and particularly dynamic flow analysis. Because now what we're doing is looking for the kinds of places in the code that are typically exploited when a pen test succeeds. And so this is great because it happens even earlier. We've shifted left, and that's what we're doing, is trying to shift security left. But it still hasn't improved the code. It still, in fact, shouldn't be finding things. The fact that it's finding things means that we haven't done a good job. So the train's coming again. I don't know which one. Coming from behind me. Is this good content? Epic B-roll? Okay, so I would say pen testing shouldn't be finding problems. It should be proving that they don't exist. They'll leave. They don't stay long. There they go. So, pen test shouldn't be finding ways into your application. If it does, it's not a secure application. Earlier pen testing that occurs before integration, relying on things like service virtualization or dummies or stubs or mocks or anything else that lets you simulate part of the application, shouldn't be finding ways into the application. If it does, the application isn't a good one. The earlier testing, SAST, especially flow analysis, looking for these same problems earlier on in the code, should also not be finding ways into the application. If it does, it's still not a good one. And this is where the really good static analysis comes into place. And a lot of people miss this. They think that static analysis is really flow analysis. Flow analysis came along later than pattern-based analysis. And so people think that it's sexier and that it does things more cool, more interesting, more important. The truth is that flow analysis works like a tester and kind of finds some bugs for you, which is cool because it can search much more thoroughly than you can, and it's a lot cheaper, and it doesn't get bored easily. But the real power of static analysis is in enforcing engineering standards, secure coding standards, not ones that say don't have this bug, but ones that say code in this manner so that you cannot have tainted data. Code in this manner so that you're never having wrong encryption methods. Code in this manner so you don't have buffer overflows. Those kinds of secure coding standards, which are also important for safety, security, reliability, and quality, help make sure that these other tests that come later can't get in. So if we're shifting left, almost the farthest left we can get from a coding perspective is checking that the code complies with the right methodology, the right practices, the right best practices for coding securely in the first place, hardening the code, not plugging holes in the code, which is really what late cycle testing does, but making better code in the first place that can't be penetrated. Again, this is like, you've got holes in the wall and you can patch them, or you can tear it down and build a wall that can't get holes in it. So that's really the value of static analysis, and it's the great bulk of it, and it's what most people miss. Most people think that for DevSecOps, they're going to run a whole bunch of pen testing early using service virtualization, and that's better than the alternative, so we've shifted a little left. And then they get excited about static analysis, thinking of flow analysis, and they've shifted a little further left. But if you want to shift much further left and start producing better code in the first place, you've got to start looking at secure coding best practices. Those ones that annoy developers, those ones that people think are always false positives, even though these rules, these checkers almost never have false positives. So it's kind of a funny dichotomy, but that's where your big value is in DevSecOps. Get the security as early as possible. So let me know what you think. Thumbs up if you liked it. Hit me up in the comments and make sure you subscribe.